Okay, we're going to talk about function notation. You use function notation to evaluate and interpret functions. You use function notation to solve and graph functions or to solve real-life problems using function notation. So what is function notation? We already know that a linear function can be written in the form of y equals mx plus b. By naming a function f, you can also write the function using function notation. So what is that? First of all, you need to know that f of x, that's how you say that. When you see f parenthesis x or g parenthesis x or g parenthesis t, the way you say this is f of x or g of x, or this one would be g of t. Now that may not make very much sense on what you're going to be doing with that right now, but that's how you say that. So we can rewrite the function y equals mx plus b as f of x equals mx plus b. When I say f of x, what I really mean is that's y. It's the same thing as y, except we don't write y, we write f of x because that's function notation. So let me take just a quick second to talk about what this means, this function notation. If I draw what I call a function machine, so this is my machine right here, and let's say our function is f of x equals x squared plus 2. Okay? When I put something in, I'm going to put some numbers inside this function or inside this machine. When they go in, they're called input values or x values. Or the domain. I can even call them independent variables. When they come out, they are called outputs or y values, and this is all review, or range, or the dependent variables. So our example for this function machine is my function f of x is equal to x squared plus 2. So let's just pick a few numbers here. Let's just say I'm going to say my inputs are going to be -2, -1, and 1. We'll just do 3 examples. So if -2, if I put in the -2, it comes inside my function machine. And what I'm doing is I'm going to put it everywhere I had the variable x. So x was in here, so I plug it in here. And then x was here, so I plug it in here. Once I plug this into the f part, I'm really done with this. This really is just to show you what value of x I'm plugging in. What this really is saying here, this f of -2, what it's saying is, what is y when x equals -2? That's all that's saying. Once I plug it in there, I'm only concerned with the part on the right. So -2 squared is 4. Bring the rest down, plus 2, and 4 plus 2 is 6. So it comes in as a -2, and it comes out as a 6. So that ordered pair would be -2, comma 6. The x value or input was -2. When it came out of the function, the output or the range or the dependent variable was 6. Let's look at the other two numbers that I selected. So the next one, I plug in a -1. So this is saying right here, what is y when x is -1? So what I'm really concerned with is this operation here, simplifying this expression on the right. Negative 1 squared is 1 plus 2. 1 plus 2 is 3. So it comes out as a 3. The next ordered pair would be negative 1 comma 3. So, and quickly, 1 goes in. This means what is y when x is equal to 1? So I simplify. Well, 1 squared is still 1. And plus 2 is 3, so it's still 3. So my next ordered pair would be 1 comma 3. Notice it is a function. None of the x values are repeating. This is a function machine, and basically what I'm trying to explain to you is all of this is what f of x is. F of whatever number you want to plug in here. Whatever variable, whatever number. So let's go back and let's look at some examples. Example 1. Evaluate f of x equals negative 4x plus 7 when x equals 2 and x equals negative 2. We have the solution worked out for us. The first thing that we want to do is we want to rewrite the function using a set of parentheses where the variable is, and then plug in the value we're looking for. The first value is x is equal to 2. Once we have that plugged in, just like when I showed you in the function machine a second ago, we just simplify the expression. Negative 4 times 2 is 8, negative 8. Bring down the plus 7. Negative 8 plus 7 is 1. That's all there is to that. When x is equal to 2, f of x, or y, is equal to negative 1. And then when I plug in a negative 2, it's the same thing. Rewrite the function using parentheses. Plug in that negative 2. Then simplify the right-hand side. Negative 4 times negative 2 is positive 8. Plus 7 is 15. So when x is negative 2, f of x, or y, is equal to 15. Let's look down at this example 2 at the bottom. And let's kind of do a little exploring, interpreting function notation. It says let f of t, no problem, it can be f of t. In this case, and something I didn't discuss, but I want to make sure that you understand, if I have f of x, or if I have f of t, or if I have g of x, or whichever, the variable that is inside the set of parentheses, this is the independent variable, always. So in this case, when I have the function f of t, t is the independent variable. It's the input value. It's just like putting x there. But the reason I'm saying f of t, or the book is saying f of t, is because we're talking about the outside temperature, T, in Fahrenheit. Actually, it's not T, it's for T hours, not T for temperature, it's T hours. I'm using T for hours, not temperature. So T is time, so after 6 a.m., explain the meaning of each situation. Well, if I have f of 0, if T here, T is equal to time in hours, what this is really saying here is when the time is 0, what's the temperature? So when they first started collecting the temperature at 6 a.m., that is time equals 0. And this is saying that at 6 a.m. it was 58 degrees because that's when T was equal to 0. And they started recording the temperature at 6 a.m. So for A, I would put that at 6 a.m. the temperature is 58 degrees, T equals 0. Part B says f of 6 is equal to n. What this is saying is, what is the temperature at the 6th hour? Or if I'm talking about the 6th hour, I'm talking about 12 noon. And it doesn't give us that data. It doesn't tell us what the temperature was. It's just asking us to determine what that means. And what this means is that at the 6th hour, what's the temperature? And then finally for C, it says f of 3 is less than f of 9. What this is saying is that the temperature at the 3rd hour is less than the temperature at the 9th hour. Or in other words, the temperature at 9 a.m., that's the 3rd hour starting at 6 a.m., is less than the temperature at the 9th hour, which would be 3 p.m. And it should be on most days. Sometimes it's not, but on most days, for this situation it is. The temperature at 9 a.m. is less than the temperature at 3 p.m. So that's how we would interpret that function notation. Let's look at some more examples. Example 3 in your textbook says, using function notation to solve and graph. Solving for the independent variable. Well, the independent variable, remember that's the one that's inside the parentheses, so that's x. We're solving for x. It says find the value of x when h of x is 7. Here I'm not plugging in anything for parentheses. This is telling me that h of x or y is equal to negative 7. So you see here that they've taken h of x and they've substituted h of x for negative 7, and now we just have an equation that we need to solve. We would add 5 to each side. 2/3 is being multiplied with x, so we're dividing by 2/3, which means that we're multiplying by 3/2. And I notice some of you that may be confusing. Make sure we use our calculator for that operation to divide by 2/3, and we get that when we divide this side by 2/3, we also divide this side by 2/3, and we get that x is equal to negative 3 when we solve that equation. Again, make sure if you're confused with the fraction operation that you're using your TI-84 calculator there, putting parentheses around the fractions. And finally, let's look at graphing a linear function in function notation. It says graph f of x equals 2x plus 5. It's the same thing as graph y equals 2x plus 5. The first thing we want to do is we want to make a table of input-output values. So I have x and I have f of x. Notice that f of x is in the place where I normally see y. Well, if f of x is equal to 2x plus 5, and I've made these table of values where x is negative 2, negative 1, 0, 1, and 2, what I need to find is what is f of negative 2? What's f of negative 1? What's f of 0? What's f of 1? And finally, f of 2. All this is saying here, this says, what's y when x is 2? What's y when x is negative 1? What's y when x is 0? What's y when x is 1? What's y when x is 2? And I can plug this into my function. Remember how we would evaluate expressions before, where I would tell you to rewrite the expression using parentheses for the variable? It's the same thing here. I'm rewriting the expression using parentheses for the variable. Once I do that, my work is very easy. I simply take what x is and plug it in. Negative 1, 0, 1, and 2. And then I would evaluate each expression. This is 1. When x is negative 2, y is 1. This becomes 3. 2 times negative 1 plus 5 is 3. When x is 0, this becomes 5. This one becomes 7. This one becomes 9. And then we can graph these using ordered pairs. When we have a table, we actually have ordered pairs. We have x, y values. Our first ordered pair is right here. Negative 2, 1. It's right here. Next, we have -1, 3 right here. Then we have 0, 5. See, right here. Pulling these from the table. Next is 1, 7. And then the final point is 2, 9. And if I plotted those points, then I could connect the dots and I have a graph. That's how we would do that by hand, and you need to know how to do that. Another way of doing this, we could use our TI-84 calculators, and we could plug this into y equals, and then we could look at our table using second graph, and it will show us our table of values by doing it that way. We need to know both ways, using the calculator and by hand.